In class today, we were able to introduce the idea of using the normal table, that left-sided normal table that I passed out to find probabilities under the normal curve. And in two of the three classes, we saw how we could find a left-sided probability, which was incredibly easy. To do that in our table, we just looked up the z-score, right? We saw a right-sided probability. In this case, we wanted to see that z was greater than 1.5. In this case, we had two options. We could look up the z-score and then subtract from 1. Because we would only get this left side probability and we needed the right side probability. We know the whole area under the curve is 1. That was option number 1, or option number 2 was to look up the opposite z-score. So we know this thing is symmetric, so the other option was to just look up the negative in this case, or if it had been negative, to look up the positive. So the one that we didn't get to in the last two classes was one of these between probabilities. So in this case, we're looking to see probability our z-score is between negative 1.2 and 2.57. So we can draw this. We know our z-scores come from a normal distribution centered at 0. We're interested in being between a negative 1.2, 0.02, I'm sorry, and a positive 2.57. So this is our area that we're interested in, everything between those two cutoffs. That's the area under the curve that we want to know about. Now, we already have some ideas of what this area is going to be like before we even get started. Just to remind us of the empirical rule, it told us that within +1 or -1, within 1 standard deviation of the mean, 68% of our data fell. So right here, we've got 68% plus some more, right? So we kind of have an idea that this is going to be a much larger probability than the previous two examples when we were looking at these tiny little tails. So what I'd like you to do now, if you have the table that we took home from class, is pause the video, try to figure out how you're going to find this probability. So there's no one way to find this probability. I had someone in class suggest, well, we can find this tail over here, and we can find this tail over here, and we can just find those two values and just subtract from 1. But that's a lot of extra work. The simplest way to do this is to just look up our two z-scores. And I kind of like this because then our method for everything is to just look up the z-score. So we get this z-score out. We have this 2.57. We're going to go ahead and look this z-score up. So I'm going to pull up my table, and I'm going to look up 2.57. So I need to get off the negative table. I need to go to the positive table. 2.57. Those intersect at 99.49. So I can go back. All right, this was 9949. And that was this whole area. Right, it's the left side area. Unfortunately, that's too much of the area, right? We can look at our original drawing. We just got all of this, which is exactly too much by everything to the left of negative 1.2. 1.02. I really want to say 1.2. So if we drew that and looked up that negative 1.2 and found everything to the left of it, well, we could just subtract that, and that would remove this extra bit we counted. So that's what you do. You look them both up, and then you subtract the smaller probability from the larger probability. So negative 1.02, negative 1.02, we get 0.1539. Which gives us that this probability is 0.8410. Now, as promised in class, there is a way to do this in your calculator. Not that the table is hard. In fact, in some respects, the table can be easier. But this is possible to do in the calculator. So, in the calculator, actually, let's start with this last one. In the calculator, I need to figure out how to bring up my... Now I'm failing miserably. I had it earlier, but now I'm failing. In the calculator, we're going to be using another distribution thing, not the binomial, because we did that previously, but we want to do normal. So if you go to your distribution section, you can see we have normal PDF, normal CDF, and this inverse norm thing. Normal PDF is meaningless. That is the probability of a particular outcome, which should be around 0. It isn't in the calculator because it's actually the one that they use to graph stuff. So we are never, ever, ever going to use normal PDF. We are only ever going to use normal CDF and inverse norm. For now, normal CDF. We want a cumulative area, an area for a range under the normal curve. If you have the TI 36X Pro or a newer graphing calculator, this is the screen you're going to see. It says, what is your lower bound, what is your upper bound, what is your mean, and what is your standard deviation? And it defaults to a mean and standard deviation of 0 and 1, which is our mean and standard deviation when we're talking about a standard normal or a z-score. The only thing we need is our lower and upper. And that you can find by looking at your drawing. What's the lower bound of the area we're interested in? So let me erase all this extra crap that I drew around this. No. Our lower bound is this, and our upper bound is here. So those are the two bounds of the area we're interested in, right? So all I need to do is type in my lower is negative 1.02 and my upper is 2.57. So go back to my calculator. My lower was negative 1.02. It's hard to type with a mouse. 0.02. And my upper was 2.57, I hope. And then I can just tell this thing to paste. And then press enter. And there it is, that 0.8411. We do end up slightly different. If we look back at our answers, we had 0.8410. There is a slight discrepancy here, and that's because the calculator is more accurate than what we have. Our table is a little inaccurate because we only have 4 decimal places. So that calculator value is actually better. So here's the calculator shortcut if you wanted to write it down. For those of you who don't have that that wizard, you're just doing normal CDF, that's our command, and you want to put your lower and then your upper. If you are using a calculator that doesn't have the stats wizard, as long as you have these z-scores, you do not need to put in the mean and standard deviation. You can just end your normal CDF here. If you have the stats wizard, you have to make sure that it says 0 and 1 for your mean and standard deviation when we're doing a z-score. So the normal CDF, or the calculator shortcut here, actually gets more difficult with the other questions, which is why I decided to start with this bottom one. So if we do the right tail probability, we still want to just think about our our lower bound and our upper bound on the area we're interested in. So the area we're interested in is right here, right? Doing a terrible job of coloring it, but this is it. We saw it before in class, this little right tail. So what's the lower bound on this area we're interested in? Well, 1.95. What's the upper bound? Well, as I said in class, technically the normal distribution keeps going forever and ever and ever off towards positive infinity. Obviously, probabilities get so close to 0 that they're negligible, but that's what we want to get in our calculator, essentially. So we have lots of options for this, but no matter what, for our lower bound, we're putting in 1.95. For our upper bound, if you feel comfortable with scientific notation, you can type in E99. That is 10 to the 99th power. That is extremely large. It is essentially infinity. I always just tell students, write in a crap ton of 9s. Because once you get out past, we know almost all of our data is within 3 standard deviations. So having any probability of being out past 9,999 is, there's no chance of being out there. So this should be enough. So we'll go back to our calculator. We'll try this out. Again, remember our original probability here was 0.0256. So I'm going to do my normal CDF again. I'm going to go ahead and turn my stats wizard off so those students who don't have the wizard can kind of see what it looks like. So if I went into my distribution menu, chose normal CDF, now I'm a sad student without a stats wizard. I have to know what to type in, and I've already forgotten what the value was that I wanted to do. No. 1.95. Whew. 1.95 was our lower bound. Our upper bound was a crap ton of 9s. Press enter, we get 0.0256, which was the exact same thing we had here, 0.0256. All right, so what do we do with the left tail probability? Again, we're just moving in from easiest to hardest, even though it worked the other way for the table. This was easiest. Now it's actually the most difficult, I think, with the calculator. So the calculator version of this one, we're still using normal CDF because we're looking for an area under a normal curve. Our lower bound, well, this is the area we were looking in, this little red shaded area. The lower bound, well, this thing has no lower bound. It keeps going forever and ever and ever off to negative infinity. It does have an upper bound of negative 1.42. So here we need to type in our version of negative infinity. So I'm going to type in negative crap ton of 9s. And then we'll type in our upper bound. So lower bound, upper bound every single time. If you have the drawing, it's very easy to see what your lower bound and the upper bound is. Just remember, going off forever to the right is infinity or crap ton of 9s, and going off to the left forever is negative infinity or negative crap ton of 9s. So the last thing I'll do is type this in my calculator. Prove to us, I'm going to use that second enter trick to bring it back again. We need negative crap ton of 9s up through negative 1.0. I should remember things. 1.42. Gives us out 0.0778, which was exactly what we had in our answer. So with that, we have gotten a little bit of accustomed to the calculator as well as to the table. We're going to go ahead and see how this works in a real question in the next video.